the CEO of RecognAIse Technologies, which he founded in 2019. RecognAIse develops an artificial intelligence augmented electric transmission line inspection system. Janos has more than 35 years of experience in the electrical utility, mining, and petrochemical industries. He has held senior positions in major utilities such as BCTC and BC Hydro, as well as other service providers such as Quanta Energized Services, where he served as Vice President of Engineering. He also runs Genomics Consulting, which provides engineering services to clients across a wide spectrum of the industrial sector projects around the world. Janos is a member of several industrial standard committees and working groups of the Canadian Standard Association, IEEE, and CIGRE on the topics of design, operation, and maintenance of electrical transmission lines. He was the secretary of CIGRE B2.61 FRP structures for transmission lines, and he holds 3 patents in transmission line structures as well as a specialty tool for live line maintenance. Janos obtained his PhD in civil engineering from the University of Arizona and NASA Space Engineering Research Center, USA. He also holds a master's in structural engineering from the Technical University of Budapest, Hungary. He is a professional engineer registered with Engineers and Geoscientists BC, as well as several states in the USA. So yeah, before we start, just a reminder to keep yourself muted. And if you have any questions during the presentation at any time, just post it in the chat and we will address it after the presentation during the question and answer period. So yeah, with that being said, I think we're all excited for this webinar. I will now hand it off to Janos, who will start the webinar.
Thank you, Carson. I appreciate your warm introduction and welcome everybody. It seems from the list of applicants, there are many people from around the world at quite a few locations. So welcome, and I appreciate your attention and then taking your time off for seeing this presentation. So when CIGRE Next Generation Network reached out to me about possible presentation, I was very happy to reply with a positive response that our company would be happy to share what we do currently. Of course, we don't share all the very details, but this is a general presentation, and I hope that it gives you a bit of a background what we do, how it is actually unfolded, and then what may even benefit your organization now or even in the near future. So the title is Artificial Intelligence Augmented Transmission Line Inspection, and a little bit about our company. RecognAIse is really, as Carson mentioned, was registered in 2019, and it grew out from my consulting business because I realized that there is an identified need from utilities. They collect a lot of data, information, images, and managing them sometimes a challenge due to many items such as resource restrictions and also simply the sheer volume of the data. So okay, so first question is, what is AI? You know, always everybody, mainly from the science fiction movies, that you get all the AI, you know, the Terminator is always coming up at every AI presentation. And I intentionally stay away from that because AI, basically an artificial intelligence, what you call it, it could cover many things. If you see, if you simply explain it, AI is nothing more than a capacity of a machine to imitate intelligent human behavior. So what does it mean? Like basically AI in its current state is a computer system that supplements human capabilities. And then it's really great to identify patterns in a data. So that's really important to see. And also it's really good to learn from experiences. So repetitive tasks can learn easily. And also, if you want to use the AI, you can use it for statistically based decision making and even potentially projections or predictions. So if you see on the right, we have this Venn diagram showing overlapping areas. So what is this like? You have the data mining, data science, big data, also the artificial intelligence kind of overlaps many things because it's really important. And within artificial intelligence, there are several subgroups like machine learning and deep learning. Even that, you have many subgroups like assisted learning, adversarial neural network learning, etc. So this is a really big area, but I don't want to go in details. It's just giving you a basic idea. And AI could be used for many, many things. And just to put a bit of a historical perspective, you may remember the history of the way back when first they invented the loom. Basically, the textile machine was a major contributor to human civilization improvement, and the steam engine and the rail. Later, when the oil and the mass production came to part, and then the computing and the digital development started. And as you see on the left, this is where we are. So we are actually at the point of a sudden rapid growth and potentially really great benefit for both GDP impact and in a very short time. That's really important, in very short time. So we shouldn't expect like decades of stagnant development. It is so quickly developing that what you develop in a year, probably within a year or so, it could be obsolete very quickly. So what is AI good for? As I mentioned, it's really good currently carrying out tasks for recognizing patterns, learning from experiences, basically that's the training, and project outcomes based on statistical analysis. So today, even what you see in AI, in this automation, it's in infancy. You may experience actually AI already in your everyday life, right? If you watch Netflix, certain recommendations of movies, or if you see like YouTube, suddenly they start recommending you certain videos. So these are the pattern recognitions, what they already use. Also great with AI, for example, speech recognition, so speech to text and also text to speech. So there are areas where the AI can highly develop very quickly. Even I saw now there is a company in AI which actually develops an AI engine which eliminates your accent when you speak. It brings it to a certain standardized English. So, but also engineering. I mean, we are all engineers, and most of us are working with either at utilities or service providers or engineering companies for utilities. So, in the current state, actually, many of the engineering tasks could be augmented with AI. And how you see it, actually, AI can learn from trial and error as well. So it's like a child. You show the child, okay, this is how you do it, and then you learn and try it again. Or like a young engineer who starts working in this area, well, first you have very limited knowledge, and there's gaining more and more experience in the trial and error sometimes, or learning it from others how they do. That's how it improves the knowledge. And then also constraints could be given and design could be delivered by AI. You may have seen some of the engineering elements when the AI could design quite a few interesting objects. And the most important part is the AI can learn from experiences. So you mess it up, okay, do it again. And you know, like in your lifetime, like 30, 40 years of professional lifetime, you can design only so many things, or you can carry out so many projects. But with the AI, you can actually automate it, and then AI can learn, like you generate certain activities, and that AI can learn from it. And then you can design, I don't know how many thousands of structures, you can do, I don't know how many thousands of system studies, and the AI can learn from these experiences and utilize it in the near future. And just show how wide is this group, how wide is this emerging technology. There is a artificial engineering applications of artificial intelligence journal. So I highly recommend to look into it because I found it very, very good. So let's go back to the inspection part, because that's what this whole presentation is all about. So inspection have two major elements. One is the collection of data, in this case mainly images. Second is the data analysis, basically evaluation of the collected data. In the image recognition part, what is on the image, what does it mean? For example, what's the ramification, risk, urgency of action, etc. And then how to document it. So let's see, what is the current inspection process? We all know that utilities do carry out some visual inspection, and my presentation focusing at the moment mainly on the visual inspection part. You see some guys are also still doing the regular way, crawling on conductors, grabbing the conductor and walking and visually inspecting literally the conductor and maybe taking notes, or I don't know how else they record what their findings are. The other part is with helicopters. There are also gimbals installed on a helicopter. You can collect images and evaluate later what to do, or you can even evaluate as you fly. So you can collect like LiDAR information, visual, thermal, corona, etc. But also a very big emerging area is using unmanned aerial vehicles. This is a burgeoning area. You can buy a relatively inexpensive UAV, and if you can make it work within the electromagnetic field of transmission lines, you can start collecting very high quality data very quickly. Also, some robots started to show up, and although some of them have been around for quite some time. In the bottom left part, you see the hydropabec line scout technology. That's a robotic system which is scrolling on the conductor and carries out all kinds of image collections and also some physical and close inspection items. But we still have other parts, like people are working on the ground, taking images as foot patrol. Also, some cases, the guys are going up and from a basket hanged out from the crane or a helicopter and then carry out certain detection. In this case, if you see X-ray images of some splicing inspection. Also see new emerging areas. What I say about image recognition and all the other parts, it could be applied for many other areas, for example, substations. This picture shows a general robotics robot at the National Grid substation in the US, and they carry out visual inspections, walks around the substation and checking out what's happening there. So why is this all this important? Because the current inspection process, you collect the data and you analyze the data and you have the final deliverable in some sort of report. So the data analysis part, when you have images, you have the image recognition, you identify again what's on the image, maybe, and then look for defects and flag the defects. You can carry out some expert analysis, what's in this, and also the data aggregation. So this actually requires quite an elaborate task from everybody involved. So what is the problem? So in North America, most of the power lines are over 50 years of age. So obviously they need more frequent inspection. The second part, utilities are swamped with image data and they are back. They have a huge backlog of inspection and they do the minimum what they can do and they do their best to carry out what they need to do. But the other part is when they inspect, it has a very high inconsistency. Even if you see the same image, same structure, it can actually could be interpreted by many people differently. So many utilities, what they have several people identifying and evaluating the images and then provide their recommendations. But also very important, knowledge loss. 50% of the industry workforce will retire in the next 5 to 10 years. And there were 20 years in North America when nobody hired anybody in the electrical utility sector. So we have the about tail end is about mid-50s and the next generation in their early or mid-30s. And then the knowledge continuity is really important. So this RecognAIse technology, what we are doing, not only simply recognizing images and defects, but also capture the knowledge of experts. So in that case, we encapsulate the knowledge of people who are evaluating the images. The other problem is the limited resources. Well, image analysis is very costly and it requires a lot of time. In our estimate that it takes about 5 to 10 minutes to evaluate one image, see what's on the image, identify issues, identify object, take notes, and then prepare them for the report. But you can imagine if you can do only 12 images in an hour, and you are Monday morning, 9 a.m., well rested, nothing, no problem. You can imagine doing it during the week, how your effectiveness would be at Friday afternoon, and what kind of work is that you are looking at transmission line images. We all know, in my view, transmission lines are beautiful structures, so maybe the public doesn't share this view, but it's really a very repetitive, very demure kind of job. So also there are emerging trends. Sensors are becoming more inexpensive. So more and more sensors expected to be installed in the field, bringing the data from the field easier than before. Just remember, we have the 5G network, and you can easily put like a $12 camera on a pole and constantly start monitoring a transmission line or a span. And but that also identifies need to monitor lines and process the data 24/7. So there is a definite need for augmenting the human activities what we carry out. In this image, you see two technologies which are currently out. Power from Iceland. Actually, they have this attachment, and then it has many measurements, but also has a camera. And in 24/7, it can measure the line, surroundings, even monitor, for example, ice buildup or other activities in the vicinity, or wind, or for example, if there is a tripping on the line, you can see it in the image right away from the control center, what's happening there. But if you deploy a couple of hundred of those equipments, similarly with others like line vision, then you need to monitor it constantly. And I don't think you can just manage it simply 24/7 by people. You need to automate this process. Also, the interesting part is the high quality of images are coming in. If you see this is a 50 gigapixel image with the size of about 320 megabytes. If you see in your iPhone, probably the best now you can get now is about 12 megapixels. And then, but now there are cameras with 3200 megapixels, which is equivalent to resolution from 10 miles away, seeing a golf ball clearly. You can imagine what kind of camera system you can use and how you can inspect actual lines. If you see on the right, this is actually part of the, let me just show it. So actually this part was enlarged here. So if you zoom in, clearly you can identify even rust spots, even that the bolts are there and what conditions are there, whether there are issues or not. So this actually shows that the quality of image is coming. And this is a 50 gigapixel image. Now it's very regular. You can get a 100 megapixel image with very large data sets. And you can imagine when you inspect transmission lines, how many of those actually, how many images are collected and what is the data set. So we are talking about terabytes of data. Okay, so, okay. Yeah. So also you can zoom in with certain images. So this is another image where you have a glass insulator, and if you zoom in, you can see so details, even the rust spots on the insulator, and then figuring out what's wrong, what's right. But again, you get thousands of images daily from these activities. So there is one possible solution. So what we propose and what we are developing in RecognAIse Technologies, where we still collect the data. We don't want to mess with this because there are many UAV companies, robotic companies, food patrols, and the utilities are still collecting data, images from the field. However, the data analysis part, so image recognition, defect flagging, expert analysis, and the data aggregation is automated. This is what we are working. And of course, the final deliverable could be either a report, a handwritten report, or something which was prepared and then automatically inputted into the utilities geographical information system or asset management systems. So how do we do this? So we use deep learning. A deep learning is actually an assisted learning part, what we work with that in the inspection process. So I was looking this area for a long time, about 2.5 years ago, when this technology emerged to the level when I felt that we could do something very meaningful. So this is when I started RecognAIse, and we did some preliminary analysis, and this is how the whole company idea came. So we do use a deep learning in a 3-layered approach. One is the recognition layer, second is the risk assessment layer, and the third one is the engineering assessment layer. And this is actually also the layering system shows neural networks are operating in this manner. I don't want to divulge into the details how the image recognition works, but it's very similar. You have layers and layers, and then you repetitively evaluate it, and then you develop a model and adjust many parameters to get the right recognition part. So about the recognition layer, so we have actually as it implies, recognizes objects and input images. So we can do like classifying the images. For example, it's like lattice star, wood posts, H-frames, etc. Also, we can identify the hardware elements, all the insulator, cross arms, vibration dampers, insulator clamps, etc. And also identify damages or defects like crack core, top hole issues, insulators, decayed cross arms, etc. So this could be all pretty much automated. And you can ask the question, what kind of images we can work with? So we definitely can work with optical images. definitely infrared images like thermal images. We can work with multispectral imagery, so you can identify even a non-visible area, whatever you observe. Corona imagery. Of course, we can deal with LiDAR. Magnetic imagery, for example, for conductors, they check many things of the cores inside. And X-ray imagery, for example, between clamps, you check what's happening to the conductors. There are those images we can all process, and particularly if you combine several images together, that could give you a really good input. So the second layer is the risk assessment layer. So we work with utilities. You have this risk matrix where you have the likelihood and also the impact. So, for example, very likely that it could cause issues, that something fails, and what is the impact on overall system. For example, if you have a highly critical, like an insulator, it's really critical, you can identify which category it falls in, and based on this, you can tell the asset management people or asset management personnel can develop the plan whether immediate, mid, or long-term response is needed to remedy the defect. Also, there is the engineering assessment layer, which is actually could be quite together with the risk assessment layer. So, first of all, you can identify from the general description of the flaw. I will show you the sample report, the possible causes. So that's actually a bit of an expert addition. Taking a note, what is the short, medium, and long-term effect, and what would be the recommended action, and also all the background information. For example, the location of the defect. This actually shows a sample. Like you have a picture where you identified, okay, this insulator was chipped, and then based on that, a simple report was generated. You have the line designation, voltage level, location, structure number. Also, there was a defect, description of the efficiency, or the recommended action, what is the risk, what is the criticality, and what is the background information on this. And this is another one which is basically repeating something similar, or the glass insulator where there is a missing glass insulator valve. So what is the advantage of the new process? First of all, it mitigates the risk, discovers potential problems before they occur. Like there is a Canadian utility, they collect about 140,000 images a year, and because of the resource restrictions, they don't really evaluate them all in details, and they had failures where they went back, and 4 years earlier they could have identified that issue and would have avoided that major outage. Also, the advantage of this, that retains knowledge, so ensures that critical skills and knowledge continuity is maintained, not only in the utility, but in the overall industry sector. The inspection is consistent because the deep learning results consistent and repeatable inspection results. That's really important. So the human bias is actually could be eliminated. Of course, there could be some machine bias that could be also remedied. The inspection is very quickly. Automation reduces inspection times and the associated cost. And of course, because you can process even several thousand images in a minute. The processing is so fast that you can even use real-time video and evaluate real-time video if needed with appropriate hardware. So of course, all the outcome is that satisfied customers, so better maintenance results, more reliable power, etc. So how does it work? So first we have to train the AI to recognize for the images. So it can do this. So what we do, encapsulating the human knowledge in such a way that a small team of experts actually evaluates the images and teaches, okay, this is the damage, this is the background, this is the object, what we need to do. And what the experts provided all the necessary information, labeling further could be done by others who do not have to be necessary industry experts. So how does it look in the real life? So it's an example where there is a UAV collected image, and then the request was to classify the images and find defects, potential issues. So in this case, the image has been marked up by hand, and of course it tagged. In this case, tagged that this is a glass insulator, and then tag for the AI, so the AI can focus on that part, identify that image part as a glass insulator. And after the training, you have a output. So the result, based on if you trained all these elements for the AI, then if you run it through, then the image parts could be identified. So for example, in this case, like glass insulator, step bolt, vibration dampers, etc. And if you see all those percentage points, it's indication how confident is the AI that what it found it is. For example, whether this is a step bolt, it's 95% confidence. This number is very similar to like a correlation coefficient in statistics. So that's what the numbering means. And after that, you can use the AI to recognize, okay, this is a healthy insulator, because like in this case, it's a glass insulator, first identified it's an insulator, and all the glass bells are intact and there is no problem with it. Or similarly, if you have another one, like you had took an image earlier, and then you have another image taken later, and you see that two bolts are missing. In that case, two glass bells missing from the insulator string. But I also brought this image up because can you imagine if you fly in a helicopter, if you have all this snowy background, it's very difficult to even identify with the naked eye what's happening there. But the AI is really good at it, identifying elements and missing and defects in this case. You see that it's almost camouflaged in the background. So it is another part is also broken insulation, detecting images. And then this is another data set where we used trained the AI to find damages in porcelain insulator. You do see that there are some other like discoloration on the surface, but we specifically trained it to find broken and cracked porcelain insulator elements, and the AI was very good at it, identifying them. This is another image I show that this is a robot running on the conductor and then collecting images, visual images on the conductor surface, looking for broken strands, discoloration, and other damages. And can you imagine this company with their robot? They have one robot collects about 6 to 8 hours of images, video images a day, and they have 9 units, so about 50 to 60 hours of images collected by day. And the analysis currently could be carried out only by watching it on the video on the screen and doing it. So actually, when this company was doing the work, the longest a person lasted was 3 days. Can you imagine doing this like a full-time job, looking at the monitor for conductors? And also, this is a very easily automatable aspect. And then, so we are working on this one as well. Another part, beside, I show you insulators and other elements, this is about wood pores. Like the request from this was that this particular company, we had a set of images, what they wanted to sort through that if you find damaged wood pores, and then this was the one that identified some woodpecker holes. So that was very quickly sorted through. That's easily and automatically done. The other part, the utility came to us and said, look, we have all these images. All we wanted to see in the first run, see all the images with the pole-top transformers for distribution. So we went through, trained the AI. Okay, this is a pole-top transformer, run it through the image set and identify that, and then it could sort it through, and you got all the images with the appropriate element. Also, we can do like not only up in the air, but in the background. This is the stubs on the ground, like the concrete foundation connected to the lattice structure. We can also either both sort the images through or identify issues. For example, in this case, you see peeling of paints, some discoloration in the concrete, etc. So this is also possible. Okay, so sorry, there was some delay in the, okay. But we can also do some other things. This image shows an image taken from the ground about the steel lattice structure, and the task was here, identify bolts which has rust elements. So this was actually the gusset plate, and you see that bolts are with some discoloration and easily seeable from what we see now on the image. I also have some other images, like this is a flashover from flashover detection on porcelain insulator. The AI can detect in this case. This is another one again. And you see this, even the discoloration, even the very tiny discoloration could be easily detected. The AI is very sensitive to it. We developed our model that it's really filtered out all the background noise. So for example, snow, grass, water bodies, or forest. So, but this shows actually the porcelain insulator with some surface issues. This is another one again. What I also like to show you that, look at in this case, there is a damaged insulator piece. So the one bell is missing. And in the background, this is again very much camouflaged. So the AI can easily pick it up and then carry out the inspection and identify the damages. So thank you very much. This was, I know it's a very quick rundown, finishing, showing what capabilities are. And I'd like to leave some more room for questions and answers. And thank you for your attention. Here's my contact information. In case you have more information needs or you want to chat about this, then please feel free to reach out to me. Thanks you. So I wonder about questions.
Thank you so much, Janos, for this very interesting presentation. So yeah, if anybody has any questions, they can either unmute themselves right now and ask the question, or if they prefer to, they can ask it in the chat. So, okay, so we have a question here from Dmitry Akimov. Are there any open free data sets?
Yes, there are some, but not freely available. For example, data sets from EPRI, there are some data sets available from EPRI, Electrical Power Research Institute in the US. And also there are some data sets from certain researchers, but not necessarily from utilities. Utilities are pretty shy about their data because they are concerned about releasing if there is some damage or some public relations issues from the images. So some are available, some are not. But it's a good question. If you have data sets, basically that's the basis for carrying out all these trainings for AIs.
Okay, great. So if you have any, okay, so Dimitri was happy. Yeah, so anybody else have any more questions they would like to ask? Again, you can unmute yourself and ask Janos directly, or you can write it in the chat. Okay, so we have a question from Laszlo.
Okay.
What is the size, number of code lines, time spent on programming of an average AI-powered software?
So code lines, it's very difficult to state because there are lots of libraries available, even publicly. The time is actually more important. It takes a lot of effort to fine-tune and develop a model. For example, we spent almost a year and a half where we reached a point where we could recognize transmission line objects, transmission line defects, and not being bothered by all the noise from the images. So meaning filtering out all the background issues, filtering out the shape issues, discolorations, etc. So it takes a lot of effort, because there are many, they call it hyper, so basically the hyper parameters, what you can fine tune. It's almost infinite possibilities. So you have to do a little bit of trial and error. But the programming code lines could be relatively simple if you know what you are doing and you are using the right programming language. But this programming of AI is not like doing line-by-line code, more of identifying statistical elements, and then in addition you have to fine-tune it and you can write your own code, and that could be a couple of hundred lines easily for each task. And also if you see the time spent on programming, so programming is quite a bit. I always being asked, how long does it take to train the AI? So depending on the hardware, it can take a long time. So you need to know that when you train the AI, it's different training the AI and then using the AI to recognize elements. So when we started the program, started the working, we used some very powerful gaming laptops for training the AI. And as for recognizing and training the AI for one particular object on a very powerful state-of-the-art Dell machine took about a week, 5 to 6 full days, 24 hours a day. And then we realized that this is not going to help us. So we built a custom-made machine, which would be probably a home gamer's dream machine with all the several graphics card and like 64 gigabytes of RAM and huge hard drives, solid-state drives, etc. and then we brought down the training time from several days to several hours. And then when you create with the training a so-called learn file, that learn file could be used for recognizing that image elements, and we use that learn file. That could be very easy, but this process actually takes quite some time. Even one image or one object detection, the training could take with the tagging, the training, etc., for a couple of weeks. So this is actually, the initial part is quite time consuming, but when you train the system and it is running properly, it's pretty quick. I hope I answered the question.
Okay, so we have another question from Dimitri again. Wouldn't you like to place this task and relevant data sets on some data science competition platform like Kaggle?
Well, we haven't really considered putting the data sets on the data science competition platforms, and for the following reasons. First, the data sets are huge. I'm talking about terabytes of data, even for one inspection set. Second, utilities are very much averse releasing any images about themselves. So, for example, we were discussing with one utility, and they were telling us, okay, we can give you the data set, but we insist that even the computer you are carrying out the training and the image processing cannot be connected to the internet. So you can imagine how far is that if you have these confidentiality requirements and then releasing it to the public domain. And then also don't forget the infrastructure inspection. I'm talking about here only about transmission lines, but this system what we develop, we can use it based on the data sets for energy generation plants. For example, nuclear power plants, we had interest from one company. They wanted to install cameras and constantly monitor the nuclear power plants. You don't want to release it to the public domain. Or similarly, you can use this approach for pipeline inspections, road inspections, airport inspection, waterways, or forestry, or some other areas. And many of these companies don't want to have that data just floating around in public. So that's the issue. With the relevant data sets, well, I think if there are open data sets, if the utilities are interested in pulling together data sets, that would be done. And I think it would be really easy to share. You're welcome.
So this is Curtis from Mexico. So thanks for a very interesting presentation, Janos. So one thing I noted is you mentioned using AI for knowledge transfer, which I think is very interesting, especially since this is the CIGRE Canada Next Generation Network. So trying to empower that next generation. When it comes to teaching an AI how to learn something that someone who's very experienced in, say, inspections and interpreting inspections, I could imagine how that side of the problem works. But when it comes to now that you've trained an AI how to do something that someone very experienced previously did, is there a way that AI can solve the problem of now teaching the next generation of how to interpret those results and how to look at those infrared infrastructure inspections?
Yes, actually, when you capture the expert's knowledge in AI, you can additionally create something like almost like a training AI, like an expert system training the engineer. So for example, you have a certain images and identify defects, and then when you collect all this information about the possible causes, possible ramifications, and possible required actions, that could be encapsulated. And actually you can write a system which would train up a utility engineer for that particular task. So it wouldn't be just simply having a black box in the background, the AI carrying out the task, but it could be sharing also the knowledge and training up. So actually it's a good idea to having almost like an AI trainer for utilities. Yeah. Okay, I have a question for Mr. Gyergyades from Hungary. I believe, so do RecognAIse work with magnetic imagery? The answer is yes. And how useful it is? I say that very useful and capture. So actually some utilities capture them. So let me just give you a bit of a background. So magnetic imagery is carried particularly out with robots crawling on conductors. And then what they are checking is the steel core and the steel core zinc coating thickness using eddy current. So the magnetic imaging from eddy current, basically checking the conductor core condition, and not only that, like a zinc thickness, which could indicate the remaining life of the conductor, but also whether there is a zinc coating still left, and if it is left, how much is the steel core remaining? Because when the steel core has directly attachment to the aluminum, the corrosion is highly accelerated. Some utilities consider when the zinc coating is gone, basically the conductor has to be removed and replaced. Mainly, actually, some utilities do carry out regular inspections, and there are systems which can carry out. I'm aware of that Hydro-Quebec has a very good system, and a robot can crawl on the line and analyze the conductor. Also, they have an unmanned area vehicle which can land on the conductor and carry out this magnetic inspection. There is another company called Kinetrix. They have a crawler which checks the steel core area of the conductor. And also there is a magnetic, there is another area where they are not really disclosing a lot. You can have sensors outside the right-of-way or within the right-of-way. And from several points, you can see how the magnetic field can change in the area or on the transmission or the distribution line. So this is actually for public safety reasons. And you can take field measurements and constantly monitor, because you know sometimes the power transfer changes and fluctuates in the line. And they want to make sure that you are not exceeding certain regulatory limits. I hope I answered the question for that. Okay. Okay, you're welcome.
So actually, Janos, I have a question. So now with this AI technology, my question is from like a insurance liability standpoint. Like, you know, if utilities don't maintain their power system and there's something caused because of that power system wasn't maintained, such as a fire or something like that, then that utility is found responsible and they have to pay a fine and whatever things that they're liable for. So now with this AI technology, would the utility still be responsible, or would it be would the AI be responsible? I don't know if you had an opinion on that.
Well, it's a bit of an interesting area because it's kind of like a gray zone. Definitely utilities are responsible for their lines. And you may remember that PG&E a couple of years ago had a failure where a simple steel shackle on the transmission line caused a fire, killing 86 people, causing so many widespread damages, and then about $30 billion worth of damage, and they made the utility bankrupt. And this was just due to lack of inspection. And even that utility, right after the fire, was going out because the regulator made it compulsory to check everything, and they collected within like 3 weeks 60,000 images, and of course they had to sort it. And they collected 50 people in one room, and only 1 or 2 transmission line guys, and they were sorting the images by hand. So as a story. But who is liable? So for example, who is liable if an engineering contractor carries out for the utility a certain inspection? Of course, ultimately the utility holds the bag, but of course the inspector does its best doing what they can do. But I think what the benefit using the AI is, you have, first of all, much higher confidence level that you find more items. Second, because of the possible speed of inspection, you can find many more items. You can also inspect more lines and find potential issues much easier. So in that case, if you have an insurance provider, maybe you can even lower the utilities insurance coverage in terms of like maybe how much they pay for the insurance coverage. So this is an unexplored area, unexplored territory. Also, who is doing the image recognition, what it is being done. Currently, we have a very strict quality assurance control. Whatever the AI is doing, it is overseen by people, experienced people, because this is supervised learning, because you need to catch certain things, not just the positive findings, but the positive false, negative forces. So what they miss, what they find, what they don't find, and all these elements. And this could be fine-tuned as I expect. As the technology improves more and more, this could be improved. But who is responsible? The legal framework has not been worked out yet.
Okay. Yes, thank you so much for your answer, Janos. You explained a lot.
Any other question from the people? If not, I can just maybe, like, you're gathering your thoughts. Many times I am being asked that, okay, so AI is replacing us, and also why should we work with AI then there will not be any jobs for us? So consider this AI, actually, this inspection, image recognition, and report generating AI. It is not replacing the person. It actually frees up the person for very repetitive, very demeaning type of job, and then frees up the time for the asset manager or asset inspection engineer or lineman for more valuable items. So they can spend more time on what matters more than just simply watching the monitor, checking out photos, sorting photos, and identifying what went wrong or what's wrong or what could go wrong. So this is actually an augmentation. This is what I emphasize. This is an augmentation for the people, and this is a tool, a very good tool set, which at some point I hope will be at the level when you have a web browser, like a window, and when you get the images, you upload the images, and very quickly you get all the images, first of all, classified. Like you want to see all the elements, or like all the splices, or all the insulators, or all the spacer dampers, whatever. And then based on that, you can move forward and then analyze them and ask questions. What could be done? What could be the potential issues? So, okay, a question. Maybe I just read it up. So glad to see National Grid robot. My name is Sid Ashok, leading the robot tech at our site. Great presentation, and looking forward to collaborate in the machine learning and other payloads respectively. Yes, thank you very much, Sid. I appreciate that. There are many robots are coming out. So the robots are working on the ground. Of course, we already have robots working on the conductors or crawling on the conductors. Now I saw actually somebody developing a robot which is climbing the lattice structure. You can imagine replacing some of the line activities, the safety point. So climbing the lattice structure and inspects all the bolts and elements. So I would be happy to share maybe in the near future when we get some cooperation with those. But we don't know what kind of other robots are being developed. And don't forget, this recognition can help quite a bit. For example, public is working around the transmission, and there is something that they don't like, or they see something unusual. They take a picture, email it to the utility, and then suddenly you can identify what's happening there, how this could be impacting. And maybe the field managers had no idea that something went wrong. Maybe like a vehicle hit the pole, or something got bent, or some corrosion issue, or maybe like a bird nest started to build up at a structure, etc. So we got some interest from one of the countries where what they do, they hire a bunch of people with smartphones, nothing more, just a simple smartphone. They send out to the field, and all they ask, okay, take photos of all the structures, all the hardware, every element, and then send us back to us, and we can solve them. And with the smartphones, they of course identify the location and all the other issues, and this way the utility can match it with the geographical information system and inspect all those things. But also the other thing, it's substation area is another very interesting area. You can have stationary cameras, or as with National Grid case, a robot walking around collecting images, maybe 24/7, like thermal images, corona images, identifying what's going on, and then in case the AI is constantly processing the images, you can flag some issues like overheating in the buswork, or something got broken, or maybe an intruder, or suddenly like a bird landed on the buswork, flashed over, or squirrels running around the bushwork on the top of the transformer, etc. So all this could be actually very easily automated using an image recognition system, and then notify the people both in the control center, also in the asset management and the maintenance side. Okay, some other questions, maybe? Thank you, Amela, thank you very much. So she just said an interesting presentation. So what I can tell you now that in North America, there are in the US about 300,000 kilometers of transmission lines, about 190,000 miles. In Canada, about 150,000 kilometers of transmission lines. In Europe, about 400,000 kilometers. So there is a lot to inspect constantly. And of course, the system is not getting younger. So it's getting older, requires more and more activities. And then the image is coming in more and more. And you may have seen that they started, in some countries, started to roll out 6G, which is the cell system after 5G, with much higher resolution, much higher data processing rate, etc. And also now you can get internet almost everywhere using satellites. So you can imagine if you have a transmission line all over the place with a remote camera, and then you don't need to have 24/7 constant stream, but let's see, take an image every hour at the tower, or take every 2 hours, or whatever is identified, checking for issues, checking for ice buildup, checking for forest fire, or maybe you had something, an event like tripping the line, and then you can check with the camera what's happening on the field. So this also could be very, very automated and could be done with the AI easily. Thank you. I don't know whether that is, I mean, you see my email and phone number, so feel free to connect to me. I would be happy to answer and give you some items, information. And if you are a utility, you feel that you would like to explore this further, please feel to contact me, and then we can figure out a good way of how AI and our system can assist your activities and ease your workload. Because the whole thing is actually, the theme is image recognition, and do something with that image, and then make actions based on the image. So it could be used in many, many different ways. Yeah. Any other questions?
Okay, so there aren't any more questions. First of all, as CIGRE Canada NGN would like to thank you, Janos, for taking your time to give us this very interesting presentation. It's definitely an exciting topic. I know AI is huge everywhere. It's nice to see it being applied to the power system industry. So thank you so much for taking the time. We greatly appreciate it. And for those of you who joined in late, we actually were recording this session, so yeah, we will post it on YouTube. If anyone wants to revisit the presentation, they can see it on YouTube. And we'll send it out to all the registrants after this. So yes, I think that's everything.
I guess thank you very much for the opportunity presenting this, and thank you very much for your attention. Thank you very much for all the participants with the good questions, and I hope maybe we can reconvene maybe a year or so later and see what progress was made, what other new things are coming out with the AI side, not only in the image recognition, but other parts, because the predictive analytics based on this and some other areas are emerging, really, really interesting areas. Thank you.
Definitely. Okay, so thank you so much then.
Thank you very much. Bye-bye.
See you later.